This is our web browser platform, so it doesn't run locally on my. This is also something. What is our experience? Hello, I'm Maximilian Grau, co-founder of Medabsy. My background is I'm application engineer.
Okay.
So I have experience especially machine vision and with the software healthcare. And we've got the idea. Okay, there's many problems in machine vision, and this occurs because you don't have the hardware. So you can only start the machine vision if you have the hardware.
Yeah.
And we thought, hey, maybe we can do it faster if we simulate the machine vision project, the whole inspection system.
Actually, I will answer that question with a question to you. You said you have experience in designing machine vision systems and implementing them. And as a question to you, what was the hardest part of the initial stages when designing an inspection system?
Yeah, I think getting the images.
Excellent. The thing is, this is something that we have experienced across the whole industry. Regardless which part of machine vision industry, it's always the question.
So when you say experienced, was it like you were working as an application engineer in an integrator, or what is
We are a very interesting theme right now. So, Max is the CEO of Medabsy startup, and I am Petra Gospodnetić. I'm working with Fraunhofer ITWM, and I'm currently together with Medabsy in Fraunhofer head spin-off program, where we are transferring Fraunhofer technology into Medabsy. So what we have here is a software that is trying to it is addressing this pain point of the data.
Maybe a short example. This is an easy example. So we are starting from the scratch. This is our web browser platform, so it doesn't run locally on my laptop. It's run on our cloud. So first we need a target, a part. This is this one. You can add normal geometric, or you can upload, for example, a step or OBJ file. At the moment, it's an OBJ file. Here we're using our standard example is always a branch. This is only to make it easy.
So you can import a CAD model.
A CAD model, yeah. Our OBJ step file is a CAD model, a 3D model, and we only needs the 3D geometry. So then we can choose here the material. We have a database with different materials. And here, at the moment, we started with aluminum. This is also something, what is our experience or what's our knowledge is the materials, how the reflection is. We are taking, for example, the first one. But if you have, for example, another project, you need a new material, we can add it, we can simulate it. So it's only to start the material because there are too many materials on the market. So now you have the object here on the platform. You can change everything, the position, of course, the orientation. You can do it really accurate here, for example, or you can do it fast. If you change here this scroll bar. So the next thing is you need light. You press here on the right side, and then you can change here the right. And we have a database with all different illuminations what is on the market. Although we want to have a database which is on the market available. We are independent of suppliers or components of brands. So let's start with this one. Sorry, and here you can add, and then you have a light. And here we are using a backlight illumination for this example. Here you can also change the position. Let's do it like this one. Takes a little bit of time. You can also be a little bit brighter. So here you can change the physical behavior. Here is depend on the voltage, as normally.
The intensity.
Yeah, for the intensity. If you have normally the most illumination runs on 24 volts. If you have less voltage, then normally the LEDs go darker. So, and the last thing is the camera. You can change also. We have different cameras here. We are using here, for example, also B&R. It's one of our customers. And here you have some the properties, for example, how much pixel they have and everything. These are data we've got from the technical sheets. You can add it. So now you have the camera here on the scene, and then we change it here a little bit. A moment, tuck, tuck, tuck. Also the orientation, because the camera is looking in this direction. And then if you press here, you see it from the camera view directly. So what we see is, oh, now it's 90 degrees oriented, but we can change everything. For example, here. So you see the wrench, and here on the left side, you can change the parameters. For example, the exposure time, aperture, focus. Later we want to expand it for more properties, but at the moment we are focusing on the main thing what you are changing. And here you can see if you have a lower number of the aperture, it means the aperture is while open, then the image goes bright because you have more light. That's normally the physical behavior. If you have a higher number, then the image is darker, but you have a bigger depth of field. It's normally the physical behavior. And here we can also change the exposure time to get more light. Or you can change here the focus to get a sharp image. Let's see. And now it's get a little bit sharper. Or you can
the diopter.
yeah. And then later, if you press here, you have a synthetic image from the camera view without hardware and only in just some minutes. This is the concept of what we are.
So I had a talk at the AIT stand, and there will be also a recording of my talk. So the landscape of synthetic data, and there you will see more about the use cases and actually comparison of the realism and what does it mean for image to be real. But just and as an example, so for example, this image that you're seeing here. So the left one is real, the right one is synthetic. And sorry.
The
So
left one is real and the right one is synthetic.
exactly.
The left one.
And this was created based on the customer sending us only the setup of their inspection system. And we use those parameters together with the parameters of the machining tool. This is the part that I was talking about, the milling, for example. So we simulated the texture, and then we had the possibility to draw this texture into different edges. So say simulate edge cases scenarios for which are physically possible but very unlikely to occur. Or, well, I mean, let's say that your tool has gotten very dull and has started producing very strange milled patterns on the surface. It would be very difficult to get that kind of data. But for the simulation, this is for example something that would not consider to be a defect necessarily. For example, it's rather it changed the texture of the surface,
an anomaly, but an
acceptable anomaly. So okay, this was now the exaggeration with very dull would be a defect. But if there is a change in the milling pattern, that would be an anomaly on the surface that is acceptable. You still need to account for that, but it's very difficult to get that data. And then for the defects, we actually simulate the defects based on the models of the defects, so we integrate them. So the customer needs to provide only the definition, okay, I need, for example, the porosities, I need the scratches, I need the cracks, and we provide you with a set of parameters saying, okay, how deep does the crack go? Does it have a widening? Does it closes? Does it have branches? That is what you can do. And you don't need the data beforehand. Or the very precious real data that you have, you save it for fine-tuning, you save it for testing, you save it for what it really matters. And if you have an AI model that you want to train, you don't want to exactly. So you use the synthetic data as a very, very useful bootstrap. Thank you.